write those down, don't worry, they'll come up right now. Okay, so a rational expression is a ratio of two polynomials. Okay, so for example, right, I could have a polynomial such as 2x squared plus 5 in the numerator, and then a completely different polynomial such as maybe x plus 2 in the denominator, right? So I have a ratio, right, with a polynomial here in the numerator with another polynomial down here in my denominator. Okay, so basically it's just a fraction denominator. It's just a fraction of polynomials, that's it, okay? So the idea of simplifying them is how can I write them in a simpler way, right? It's like a fraction, right? Like if I had a fraction such as 5/10, I know that 5/10, I could reduce that fraction to 1/2 by dividing top and bottom by a certain number. So that's the idea here. It's the exact same thing, but it involves some factoring because sometimes you don't see the thing that they have in common that can be divided out, okay? And so that's where we're gonna start. All right, so please feel free to ask questions as we go. Don't be shy. It's a slightly new concept. The factoring is not new, right? So I'm gonna make the assumption that you're still okay with factoring. If you've gotten a little rusty, that's okay, but hopefully it comes back to you, all right? All right, let's move on then. So what we wanna do here is simplify each rational expression, and I'll zoom out a little bit for those of you who are still copying the first one. So with simplifying, the first thing is you look to factor the numerator and something from the denominator as well, okay? You're looking to see like, okay, I wanna factor whatever possible because I wanna try to cancel something out. I wanna divide out a term from the numerator and the denominator, okay? So for example, 10a squared, well, there's nothing really you can factor out of that because that's a monomial, right? So there's not much. However, what do you notice about 10, 4, and 6? Okay. If you look at 10, 4, and 6, well, they each one of those values can be factored by a 2, right? You can factor out a 2. Okay, so I'm gonna actually start with the denominator first because there's more terms down there, and then I'll be able to find out, well, what can I factor out from the denominator that can also be factored out from the numerator, and then I can cancel them. Okay, so if I start in the denominator, what I'm looking for here is a GCF between 4 and 6. So I know that this is represented as, well, I can factor out a 2 from both, okay? And they also both have a as a variable, right? So then they both have a, that means I look for the lowest power, a to the first power, so I can factor out 2a. Okay, this is just in my denominator, by the way, okay? When I divide this by 2a, that's gonna leave me with 2a. When I divide this by 2a, that's gonna leave me with minus 3. Okay, so now I have a 2a factored out from the denominator. Okay, now in the numerator, okay, you might think like, okay, well, if I look at 10, notice how 10 also has, it could be divided out by a 2, and then a could also be divided out by a. Okay, so here what we can do in the numerator is say, well, okay, if I were to factor something out of that 10, maybe I could write it as like 2a, and then what's left over? Well, if I divide 10 by 2, I'm left with 5, and if I divide if I divide a squared by a, I'm left with 5a, okay? Now, why did we go through that process? Well, it's because notice how we were able to factor out a 2a from both the numerator and the denominator, right? Because that's the term that they both have in common, that's the term that gets divided out, okay? Basically, it cancels, right? We kind of call it that, but it gets divided out. So really, right, That's what happens, right? So then we've basically reduced the fraction into the simpler form now, which is 5a all over 2a minus 3. And so then this would be right here, the simplified version of our expression. Okay. Are there any questions so far about what I just did? Okay, so the whole goal here is to factor out things that are in common, right? Trying to factor them out as simple as possible, trying to find that one term that they could have in common so that you can divide it out and you can cancel it out. And then you just bring down whatever's left. Okay. All right. Let's move on to number 2. Okay. All right. So let's see. Let me see if I can resize this. It's a little big. Okay, so this time we have two trinomials, right? Trinomial in the numerator, trinomial in the denominator. Remember, the goal here is, well, we want to factor out something that they have in common, but it has to be in factored form first. The last thing that you are allowed to do is say, okay, I have m squared, I have m squared, I'm going to cancel those. Doesn't work that way, okay? Because what we needed to do is have it factored, because what you need is a product of the two terms. A product here and a product here. And once you have it as a product in the numerator and product in the denominator, then you can cancel, but you cannot just simply cancel them, because right now there's no product. That's just m squared minus 10, and that's m squared minus 11. There's no product there, okay? So please don't do that. That's a common mistake that I see sometimes. So look at the numerator, right? And we want to factor this. Now, whatever method you're more comfortable factoring in, please do that, okay? So if you're the person that feels comfortable factoring using the box method, please go ahead, feel free to do that. I'm gonna go factoring with the method I feel the most comfortable with, and also because I can kind of see it already, that if I wanted to factor this m squared minus 10n plus 25, numbers that multiply to be 25 but add up to be negative 10, that would be negative 5, okay? So in this case, this is going to factor into m minus 5 times m minus 5. Okay, so you see here, I've created a product, right? A product of two terms, right? That product is clear, separated by those sets of parentheses there, okay? In my denominator now, I'm looking for factors that multiply to be 30, but add up to be negative 11, okay? So factors of 30, 10 times 3, 5 times 6, okay? If it's multiplying to be positive, then I know that both factors need to be negative. So in this case, it's going to factor into m minus 5 times m minus 6, right? And then, of course, if you feel like you need to do your happy face check on that, then feel free to do so, all right? But again, I'm moving on with the assumption that you're pretty comfortable with factoring. So now that we've factored these out, notice that they have some terms in common, right? They have m minus 5 over m minus 5, right? Those two terms are something that could be divided out, okay? So because they can be divided out, that means basically these entire expressions cancel, and you're only going to be left over with m minus 5 over m minus 6, okay? And then that is it right there. Any questions on number 2, example 2? Yeah, it is kind of fun. Yeah, it's like, okay, I'm factoring and I'm looking to see what I can cancel. It's kind of cool. All right. All right. Next up, number 3 then. All right. So the one in the numerator, right? We just have 2 minus x. There's not really much there to factor. There's no GCF between 2 and x. So let's just bring it over as 2 minus x. And then in my denominator, can anybody tell me what we call something that looks like this? X squared minus 4. There's a name for it. Does anybody remember? Yeah, perfect square. Yep, they're both perfect squares, and because there's a minus in between, it's a difference of squares. Okay, good, Selena. All right, so here when we factor this, remember that this is just an easy split. It's just x times x, and then this 4 is just 2 times 2, right? So when you factor this, one of them is positive, so you get x plus 2, and then the other would be x minus 2. Sorry. All right, so then we're looking to see if we can factor something out, right? We did factor it, and now we're trying to see if I can cancel anything. Thank you. All right. So right now my term in the numerator is 2 minus x, and it looks similar to x minus 2, but it's not. All right. This is a common mistake that I see sometimes. I've made the mistake before as well, right? I'm kind of rushing through the problem, and I think that x minus 2 is the same thing as 2 minus x, and it's not. Let's just think about why it's not. Look at the x down here, right? This x is a positive, because if you look at the sign in front of the x, there's nothing there, so it's a positive. The 2 is negative, okay? Versus at the top, this 2 right here, that's a positive 2, and then the x is the one that's negative, okay? So right now they don't necessarily match. They're not the same term yet, okay? But there is a way that we can get the numerator to look like the one in the denominator. We just have to be creative about what we do here. Typically, this isn't something that we do unless the leading coefficient is a negative, but I could, if I really wanted to, factor out a negative from the numerator, okay? If I were to do that, basically what I'm saying is I'm going to divide the numerator by a negative. So I'm going to take 2 divided by a negative, which makes it a negative now, okay? So then if I factor out a negative, here's what I get, okay? If I factor out a negative, well, since it's a positive 2, I'm dividing by a negative, now that becomes negative 2. And if I take negative x and I divide it by a negative, now that becomes positive x. Okay, and if you don't believe me, just FOIL the negative back in, right? If you FOIL the negative back in, you're gonna get negative times negative, that's a positive 2, that's the one right here in green, and then negative times positive x, that's a negative x. Okay, so by factoring out the negative, you basically just flip the sign. You turn the 2 into a negative, you turn the x into a positive, okay? And then let me bring this over now. I have x plus 2 times x minus 2. Okay, so to you, to your eyes, it might still not look the same, okay? But now, watch this. In the numerator, I could still leave my negative out there, but I can rewrite the expression. I can write it as x minus 2, right? Just kind of flip them around, because the x can be brought to the front as a positive and the minus 2 brought to the back. Now, if I bring down the denominator terms, I have x plus 2 and x minus 2, okay? So do you see how now we've been able to create a rational expression here where we have the same term in the numerator and the denominator, so now we can cancel out x minus 2, okay? So now we're left with negative. Since there's nothing in the numerator, we can just leave it as a negative 1 all over x plus 2, okay? Any questions on this one? This one is definitely a tricky one, because it involves being able to manipulate the negative and factoring out a negative when we're usually not used to doing that unless the leading coefficient is a negative. How do we feel about number 3? We're okay? I see a thumbs up, the thumbs up, looks good, okay. We're good, all right. Awesome, all right, let's move on then. All right, let's take a look at this this next one. Example number 4. Okay. So right off the bat, I noticed something that was very magician. Yeah. Math magician. Okay. All right. So let me hear some feedback from you guys. Where should we start on a problem like this? Any ideas? GCF. Okay. GCF for numerator or denominator? Which one? Both? Okay. Yeah, we can do that. All right. So let's start with numerator then first. Yeah, I was gonna try GCF as well because I don't want to try to factor out a trinomial that has a leading coefficient that's not one. Those are harder to factor, right? So if you notice 3, 9, and 12, they can all be factored by, yeah, 3, right? So we factor out a 3. So we're gonna divide every term by 3. So then the 3 goes out front. Now we're left with x squared minus 3xy minus 4y squared, okay? So it's much easier now to think of numbers that can multiply to be -4 and add up to be -3 than if you were to try to figure out how to factor the numerator without pulling out the GCF first, okay? So I have a GCF of my numerator. I'll deal with factoring the rest later because I want to see if I can factor out a GCF from the denominator. All right, denominator. What do you guys notice is the GCF there? 6x, beautiful. Okay, so I get 6x that I get to factor from the denominator. If I factor out a 6x, what is left? What would go inside as, let's say, x squared minus y squared? Yes, sir. X squared minus y squared. Good, okay. And now we have somewhere to start. Okay, good. So, all right. Before we start canceling anything, let's factor everything, all right? I know you might be tempted to reduce the 3 and the 6, okay? But let's just hold off on that just for now, okay? Let's clean up everything and then we can make that decision about what can we cancel out, what can we reduce, all right? So let's go back up here to our numerator, all right? If I wanted to factor, remember to bring that GCF with you so that 3 comes over, okay? I know that this is going to factor into, right, 2 different terms. I know that x squared, that breaks off into x times x. And if I want to get a product of -4, but a sum of -3, well, let me think about what the factors of 4 could be. It could probably be a -4 and a +1, right? So -4 and +1. Now, another thing to notice is that you're factoring not just 4, but you're factoring 4y squared, okay? So you're going to need a y here and a y here. Okay, now again, this is something that I'm able to do because this is how, like, this is the method I've learned it. But if you want to do a box method and you feel like for me to really understand what Samoza is doing, I need to kind of do a little bit of side work and do the box method, please do it, okay? In fact, I'll do it with you right now for those of you who like doing that instead. Remember that box method, you take the factors A and C, you multiply them together, so you're going to get -4x squared y squared. Okay, and it needs to add up to be a -3xy. Okay, so what are those potential factors? Well, in order for that to happen, I think we could probably take -4xy. No, wait a minute. Yeah. -4xy and a +1xy. Right, and so we get the product of these two and then the sum of those two, right? And then if you then go over to your box method, right? Remember that the leading term was x squared, so it goes in the front. Then you have -4y squared, that goes in the bottom right. You would use -4xy and then you would use 1xy here as well. Okay, so then you would want to factor out your GCF across each row and each column. Okay, so along the first row, the only thing they have in common there is x. Along the second row, what they have in common there would be a negative 4y, right? So then you see how that term x minus 4y, that's what we got, the first factor. Along the first column here, what we have in common is just x, and then along this column, we're looking at y, right? Just x plus y. So that's the same thing that we got, all right? So that's what we have so far. All right. You guys with me so far? That was just a little bit of a review there for our box method people. Yeah, okay. Okay, and then now let's take a look here. Well, we know that we were gonna bring over the 6x. And then we looked at one of these earlier, right? We have a perfect square and another perfect square, and there's a difference, there's a subtraction in between them. So we know that this factors into x times x, and this factors into y times y. When it's a difference of squares, one factor needs to be positive, so x plus y, and then x minus y. Okay, so clearly which one is the one that is going to cancel out for us? Which one is the most obvious one? Yeah, x plus y, that's the winner for today, right? So then those cancel. Okay, we're gonna bring down the rest. We have 3 times x minus 4y all over 6x times x minus y. Okay, let me write this for a little bit better. Okay. All right, so now notice these factors, x minus 4y and x minus y, are not the same. Okay, they look like they could be. You know, you might be tempted to cancel out the x and cancel out the y's and then just leave a 4. That's not the case. Okay, if inside of the parentheses it is not the same term, do not cancel it out with anything else. Okay, it has to match exactly. Whatever is in my parenthesis in the top has to be the parenthesis in the bottom. Okay, I'm only letting you know because these are the mistakes I've seen in the past. All right. Now, there is something else that can be simplified. 3 and 6, whole numbers are never excluded from being able to be reduced, right? So if it was anything else, right, imagine that you're only looking at 3 over 6, that can also be reduced, right? So if you divide the top by 3, that becomes 1. And if you divide the bottom by 3, that becomes 2. Okay, so now you just want to read it and leave it in the simplest form. Okay, so since that becomes a 1, you don't even need to write it. You can just write x minus 4y. Okay, and if you like the parentheses around it, then obviously you can leave them. And then down here, the 6 became a 2, so now it's 2x times x minus y. Okay, now you might be wondering, like, okay, after we do all this, do I have to distribute the 2x back in? No. Okay, with rational expressions, it's best to leave everything in a factored format, and then you cancel out what's possible. If there are leftover terms, you leave them. Don't FOIL them back in. Okay, sometimes you might, like, let's say you're taking like an S back. Yeah, probably if you were taking the S back, just know that it's possible that they could show you the solution where they did distribute the 2x back in, right? So you might see an alternative answer and an equivalent expression that also says x minus 4y all over 2x squared minus 2xy. Okay, just to let you know that that could happen, but for me, you don't need to distribute the 2x back in. Okay, does that make sense? I don't want you to waste time doing that. Okay, you can leave this as your answer, but I want you to recognize that other exams like the SBAC or the SAT especially will give you either this option, or sometimes they give you this option and you have to select it as it being the right answer as well. Does that make sense? Yeah, okay, good, all right. You know, tricky tests. All right. There are gimmicks. That's right. Okay, let's take a look at the example. What is this, 5? I believe it's 5. Okay, so somebody get me started here. How should we approach number 5? All right, GCF of which term, which polynomial? Numerator or denominator? All right, both. Yeah, okay. All right, so if we have a GCF for both, let's start with the numerator first then. What do you notice could be factored out as the GCF for that numerator? What do they all have in common? Yeah, x squared, right? They all have x, and the lowest power they share is power of 2, right? So we can factor out x squared. So x squared comes outside, and now everything else left inside, we were going to divide out x squared, right? So then we're going to be left with 2x squared plus 9x minus 5. Okay, good. Now denominator, what's the GCF there? Yeah, just x, right? Just x. So we factor out x, so now we're left with 6x squared plus x minus 2, okay? All right, so you might feel like, okay, I factor out the GCF, and I can cancel those x's out, and then I'm done. Well, remember, you got to try to factor out these trinomials, right? As ugly or as messy as they might seem, that's our goal, okay? So let's go ahead and come over here off to the side. We need to factor both. Let me move this out of the way. Okay, so let's go box method here, right? Because we have a leading factor of 2, I think box method could be useful. All right, so we want to multiply -5 times that 2x squared. That's going to give us a -10x squared. And it has to add up to be a positive 9x. All right, so what could we do here? What potential factors could give us a sum of -10, but a product of -10, but a sum of 9? Yeah, it looks like 10 and -1, right? And then obviously x with them. So let's do -1x and then positive 10x. Okay, that seems like it works. Now let's go ahead and put that into our box. Okay, so the leading term, the 2x squared, that's what's going to go inside box number 1. -5 will go into the 4th box. And then we can just go ahead and plug in -1x and then positive 10x here. Okay, so now let's go ahead and find the GCF across each row and each column. So if we go across the row, there 2 and 10, they can both be factored by 2, and they both have x in common, so that's a 2x. -1x and -5, well, they both have, remember, the leading coefficient here is a negative, so we're going to factor out -1. Okay, and unfortunately, they have nothing else left in common. All right, if we look at the first column, let's see, there's a 2 and a -1, there's x squared and x, so it looks like the only thing they have in common would be x. And then between 10x and -5, the only thing they have in common there looks like it would just be a 5. Okay, and that's a positive because I'm looking at my leading coefficient being 10. Okay, 10 is my leader. All right, so that tells me there, okay, I have my two factors. I can then go ahead and factor this into x squared times 2x minus 1 times x plus 5. And I believe that's correct. All right, so now let's move on and let's go down to the denominator. All right, denominator, I'm gonna bring that x over, and now we're gonna do a little bit of x box method down here for the second trinomial. So we're gonna multiply a times c, that's gonna give us -12x squared. And it has to add up to b, well, there's no number here, so we can go ahead and put a 1. So that means it has to add up to be a positive 1x, okay? What do you guys think factors, what factors can multiply to be a negative 12 but add up to be 1? For negative 3, yep, I agree. I agree. So let's go ahead and use a 4x and a negative 3x. All right, so now let's box this guy up. All right, so we have the leading coefficient, the leading term, which is 6x squared. And then our last term would be negative 2. Our two different terms would be 4x, and we have negative 3x here. Okay. All right, so first row, like 6 and negative 3, we could factor out a 3, okay? And then between x squared and x, we could just factor out x. Okay, between 4x and negative 2, that looks like we could just factor out a 2 there, right? Positive 2. All right, across the first column, 6 and 4, we can factor out 2, and then they both have x, so we can factor out 2x. And then between negative 3 and negative 2, there's not much that they have in common besides, well, the leading coefficient there is a negative 3, so you can factor out at least a negative 1. Okay. All right, so now let's go ahead and write out our factors. So we have a 2x minus 1, and then we have a 3x plus a 2. Okay, and just doing a quick check here, that's a negative 3x, that's a positive 4x, that's a negative 2. Okay, all right, so you can see there who is the term that is going to divide out. Yeah, 2x minus 1, right? So we can we can divide out 2x minus 1, so they're gone, they cancel, right? All right, now notice something else too. You have x squared divided by x, right? So if you have x squared divided by x, well, here, these are going to cancel each other out as well, right? Except here, because I have x squared divided by x, the x goes away, and instead of having x to the power of 2, now that just becomes x to the power of 1, okay? So now your final answer, you're going to have x, no longer 2x minus 1, you only have x plus 5, so x times x plus 5 all over, in the denominator, x canceled, 2x minus 1 canceled, so the only term you have in the denominator now is a 3x plus 2. All right, and so there is your final expression. Okay. Any questions there? No questions, all right. No questions. Good, okay, sounds good, sounds good. All right, so now let's just go ahead and finish off with this last one. This last one, what is it that you notice about that numerator? How are we going to approach factoring something that has 4 terms? What's the magic word here? Split to 2, that's right. You're going to split it into 2 groups, right? It's factor by grouping, okay? You can't do normal traditional factoring on something like this. So we split it, okay? So we would split after the second term, and we look only at the, we look only at the first 2 terms, right? So right now I'm not going to do anything with the denominator, I'm just focusing on the numerator. Those first 2 terms, what is it that they have in common? What GCF can be factored out of those first 2 terms? Yeah, x squared, right? So we factor out an x squared, okay? So then I'm going to go ahead and write this as x squared, and then what's left over there? if I factor out x squared? Yeah, we have a nice little x plus 4 left over. Okay, now, second two terms. All right, you have negative 9x minus 36. That means your leading coefficient is negative. So what can you factor out from both terms there? What is the GCF going to be? Yeah, we got a negative 9, right? So now we have a negative 9. And then what is going to be left over when you factor out a negative 9? Yeah, we got x plus 4 again, right? Which is what we want, right? So remember that when you're factoring by grouping, remember that what you want is you want the same term inside of these parentheses. Because if you don't get the same term inside the parentheses, then something went wrong, okay? So now we look for, well, what is the new GCF of everything that we have here, right? What is it that both of these two terms have in common? Well, that new GCF is going to be x plus 4, okay? So x plus 4, and then the two terms that were on the outsides, the negative 9 and the x squared, those become the new term, x squared minus 9. Okay, so we just take those two outer terms, and those become the new factor, okay? All right, so at least we've been able to take that numerator, right, and we've turned it into a couple of factors. Now, I have x plus 4 times x squared minus 9. What do you guys notice about x squared minus 9? Perfect square. That's right, right? X squared and 9, they're both perfect squares. So because there's a minus in between them, it's a difference of squares, okay? So this is the one that factors into x times x and 3 times 3, right? So we're going to factor this just one more time, okay? Again, this is all just the numerator, right? So I apologize that it's kind of messy, but we know that that's going to end up giving us just the numerator. Well, it's the x plus 4 still, but x squared minus 9 factors into x plus 3 times x minus 3. Okay, so always be on the lookout to see if after you've done one round of factoring, can you then factor whatever is still there. A lot of times we're gonna throw in some difference of squares in there for you to see if you catch them, right? Did you catch the difference of squares? Did you realize that you could factor that down further into now you have a product of 3 different terms? Okay, so that's all numerator work right there. Okay, now let me put this over the denominator. Okay, because my denominator is still 4x squared plus 28x plus 48. Okay, is there anything we could do to help us simplify that denominator a little bit before trying to jump into like a Xbox factoring? Yeah, they can all be divided by 4, right? A GCF of 4. So let's do that. Let's factor out a 4. So if we factor out the 4, 4 goes out. Okay, and if we divide everything here by a 4, 4, and 4, let's see what we're left with. The 4s would cancel, so you're left with x squared. 28 over 4, that's 7, so that's 7x. And then 48 divided by 4, that's a 12. Okay. Okay, so some of you might need Xbox method for this. Some of you might not, right? Because there's no leading term in the front, it's a little bit easier. So just think about numbers that can multiply to be 12, but then also add up to be 7, right? Factors of 12 that add up to be 7. Let me start bringing everything over while you guys think about that. Right? Once you figure out what those factors are, just let me know. Okay, so 3 and 4, that's right. Okay, so if we were to factor this, we have two terms. X squared factors into x times x. And in order to get 12, right, we need 3 and 4, positive 3 and positive 4, right? So we get positive 3 and a positive 4, okay? And check that out. Right now, we have multiple terms that can be divided out because I have an x plus 4 in the numerator and an x plus 4 in the denominator. These divide out. I have x plus 3 in the numerator with an x plus 3 in the denominator, so those also divide out. So what's left? Well, the only thing left now is I have an x minus 3 in the numerator And the only term in the denominator is 4. So then this is my new expression. Okay, that's my expression in the most reduced form. Okay. Any questions on our last example? Okay. I personally like this a lot. I think this math is kind of fun, right? You look for the pieces, you factor, and then you cancel. I think the canceling part is like really satisfying, right? Being able to factor it into something that matches on the top and the bottom, and you're like, yes, like I know I got it. Typically, you know that you may have made a mistake when you don't find factors that are in common that you can cancel out. So it's a good way to your work kind of checks itself for you. Okay.